First term is 4? You sure? So here's the thing. What type of series do you hope this is? If you start at 4, is this a geometric series? No, because the ratio from 4 to y is y over 4, and then it's not y over 4 for the next one, right? So this one has like a cheap kind of aspect to it. It's 4, right? Which is finite, plus what? All of this. It's 4 plus all of this. So what you do is you just do 4 plus the rest. So if you were to do it that way, 4 plus the rest on this one, so we're really just looking at this right here. How would you go about doing that, Xavier? The ratio is what? And what's the first term? Y. So what's the sum going to be? What's the sum going to be?
Y
times
1 minus y
to the that thing to the n, right? Like this? All over what?
over 1 minus 1 minus y.
1 minus y over 3. And what is n going to? N's going to infinity. So you agree that the sum, if you add these two things together, will be 4 plus that, correct? So, converge. Converges when what is true? Sorry, when the absolute, so let's start, don't do any math here. So the absolute value of y over 3 has to be what? Smaller than 1. The ratio has to be smaller than 1. R has to be, if it's equal to 1 or greater than 1, what happens? It diverges, right? So if we want it to converge, that has to be true, which means that y over 3 has to be between these things, like that, right? So what does y have to be between? 3 and negative 3. Exactly. Yes. When y is between negative 3 and 3. If it's outside of those values, it will diverge. Boom. Effectively, what this entire thing boils down to is, do you remember how to do this? 1 to infinity of 1 over x squared dx. Do you remember how to do that? What kind of integral is that? Do you remember? Yeah. Improper. Nice. Improper. Very nice. There's different ways to be improper for improper integrals, but what's the thing in there that makes that an improper integral? Close. The infinity. You can have 1 over functions and that can be a proper regular integral. It's the infinity. Now here's the thing. Can you plug in infinity? What? Is infinity a number? No, it's not. So when you run this, can someone just tell me what is the integral of 1 over x squared? What is the integral of 1 over x squared? Yeah, negative x to the negative 1. And if this was like 7, we could just plug in 7 and 1, do the fundamental theorem of calculus, and be done with it, right? What you need to do first, you might remember this. This is the same thing as saying the limit as, say, b goes to infinity of 1 to b of 1 over x squared dx. Do you remember doing something like that? No? Well, now you're getting reminded. So these are the same. These are the same. So instead of plugging in infinity, we're plugging in b, and we're going to take a limit after we integrate. So x, you just told me what the integral is, right? What is it?
Negative 1 over x.
So yeah, I like that. Negative 1 over x. I like that. Negative 1 over x, right? And you're going from what? 1 to b? Everybody with me so far? Haven't done anything really earth-shattering yet. So then we have the limit as b goes to infinity of what? Negative 1 over b. Then what? Minus what? Negative 1 over 1. Is it really easy to lose a negative sign here? How am I doing? Am I okay so far? Zoom out a bit? Yeah, sorry. How am I doing? Am I doing okay? So you're going to end up with the limit as b goes to infinity of negative 1 over b plus 1. Are we okay with that? What is that limit right there? It's just 1, right? As b goes to infinity, what happens to this thing right here? What happens to that? It goes to 0. Do you agree? So here's the thing. You need some way of linking this integral right here. You need some way of linking that integral to the 1 over n squared. Well, there's a nice picture. What does 1 over n squared look like? A nice way to visually see this is the following. Kind of looks like this, right? That's the function 1 over n squared. Are you okay with that terrible graph I just drew? You okay with it? Well, what's the first term? 1. Well, let's plug in 1 into this. What's 1 squared? Or 1 over 1 squared is going to go up to here. So if that's 1, what's the area of that box I just drew? What is it? 1. What happens if I go over to 2 right here? What's this coordinate right there? 2 comma what? 1/4, right? Because the function is, it's this function right there. I'll write that a little cleaner. That's not super nice. F of x is, or f of, 1 over x squared. Are you okay with that coordinate I just wrote right there? So what's the rectangle I could draw now? This one, I'll highlight it in red here. What's the area of this one right here? What's the area of that one?
1 times 1 over 4.
Yeah, 1 times 1 over 4, right? Where do you see 1 times 1 over 4? Where I see it right there and I see it right there. What's the next rectangle I could draw?
1 times 1 over 9.
Yeah, so it's 3 comma 1/9. What's the area of this one? 1 times 1 over what? 9. And do you see that one there? Yeah, here's the green 1 over 9, and then it's right there, and it's also right there. So do you see how I've placed this series underneath this? We just proved that this, from 1 to infinity here, we just proved that 1 to infinity here, when we integrate it, what does this thing add up to? Well, we did the integral, it adds up to 1, right? So we just did 1/4. What did we do here? We just, the integral 1 to infinity here. 1 all the way to infinity, what does it add up to? 1. Well, all these pieces are less than it, and we're just adding this one singular piece there, so therefore what must this do? It must converge as well. We prove that it's less than converges. We prove that it's less than converges. So here's the thing. You're going to get a series, and you're like, I'm not sure, but if you find a function that it's always less than, and then you integrate across at least, integrate across the domain, and you can integrate it to 7, or 8, or 15, it means that the thing that it's above also converges. If this converges, then what? Everything below it converges. Yes, Gabe?
So like the graph basically means like the graph.
Integral do we need to do, Xavier? What integral do we need to do? Well, hold on. I didn't tell you. You're just skipping ahead. You're just skipping stuff. So you want to do the what integral do we need to do? Infinity of, you could say x. Doesn't really matter. X or n. I'll fix it. I'm fixing it. There we go. We need to run that integral. Do you agree? Right? Can you plug in infinity? No. So you need to write it as a limit. Please write it as a limit. So when you rewrite it as a limit, it's going to be the limit as x goes to infinity of the integral, not x, let's say b going to infinity, 1 to b of x over x squared plus 1 dx. What method of integration can you use on this one? Anybody raise their hand and tell me? What method can we use? Substitution. Some people call it W substitution. I grew up in high school calling it U substitution, so I might go back and forth. What should I make U equal to, KU? Yeah. So therefore du is equal to 2x dx. So what does dx equal? Du over what? 2x. I know you guys did this in maybe a different order. You might substitute it and then simplify a little bit. I like doing this isolation first. Okay, so now when I do that substitution, what do I end up with? The limit as b goes to infinity, the integral of x over what? What? Come on, kids. What is x squared plus 1? U. And what is dx equal to?
2x du.
Yes, du over? Yes. What's the magical thing that happens right now?
X.
The what cancels?
X.
If the x didn't cancel, are you very sad? We're not doing multivariable integration yet, right? We're not doing partial derivatives. So what do we have now? We have the limit as b goes to infinity, integral of 1 over u du. What did I not write in?
2.
I didn't write in two different things. What did I not write in? What did I not write in? What are those circles called right there? The limits of integration. What are the limits of integration now? We went from it in terms of x to a u, so what is it now? 2 to what? It goes from 2, I agree, but what does the upper one go to?
It's still infinity.
It's still infinity, but let's be careful here. What is the top going to go to? B squared what? B squared plus 1. Is everybody with me so far? I wrote plus 1, didn't I? Right? I didn't say it, I'm sorry. The reason I do this here, even though it doesn't, quote, matter, is because what's the number one way people mess up substitution? They keep the same limits and then they forget about it and they make a simple mistake. So now we actually do this. What is the integral of 1 over u? ln of u, correct? And we're going from 2 to b squared plus 1. The limit as x goes to, sorry, b. I keep on doing that.
Where did the 2 go?
Ah, where did that come from? See this, Xavier, right here?
No, I mean, from the line written in green, the d over 2.
Oh, there's a 1/2, isn't there? Sorry, you're right. You're talking about that one right there? Yeah, there you go. Is this better? Sorry. Thank you, Xavier. That's exactly the kind of thing I need help catching. Exactly. Are we okay? Yeah. Let's plug in. We can plug in the b squared plus 1. What do we end up with? 1/2 the limit as b goes to infinity of what? ln of b squared plus 1 minus ln of what? 2? Is that correct? Everything there is pretty nice-ish. This is finite, right? 1/2 just along for the ride. What about this? What's the limit? What's the natural log of b squared plus 1 as b goes to infinity? Oh, come on. What's the natural log of a billion? Very big number, right. This thing goes to what? That goes to 2. That's finite. So what does this whole thing go to? It goes to what? Positive infinity, right. That goes to positive infinity. That goes to positive infinity. So let's go back up here. We had this rule right here. What does it say? The integral test?